Hi, everybody. Welcome to Facebook. Thank you for coming. I hope everybody's enjoying the Mobile at Scale conference so far. Just a little introduction to myself. My name is Alan Canestraro. I've been at Facebook for about a year. Prior to that, I worked at Apple for 12 years, working on iOS. Right now, I have a team out in London. I'm actually living in London, UK, and we're building Newsfeed for iOS. So super excited, and trying to build out our presence over there. And what I want to talk to you today about is how we build our Facebook infrastructure on iOS. I think you've heard a lot today already about some of the history, so I'm going to skip some of that. Anybody tell me what this is? This is Facebook version 4 when it was a web app. So we've gone to native. We've gone to native, and Facebook has been really, really good at building out our web infrastructure, our website, and all that stuff. But when it came to building mobile, it was a big transformation for us. So I want to take you through some of the choices we made in terms of how we structure our teams, how we develop our product. We'll look a little bit into our toolbox and some of the different classes that we use that I thought were interesting. And then we'll talk about how we test at such a large scale. First, very briefly, I want to talk about our teams at Facebook. And this one's pretty straightforward. What we've done at Facebook is I don't know if you've heard today about the way that we have our product team structured. But at Facebook, the Photos team, the Feed team, the Search team, Places, all these different teams build the same part of the different platforms, right? So the Messages team actually builds the iOS part, the Android part, and the web part. And so the way we structured our teams is something I like to call a team sandwich. We have a product infrastructure team who actually builds the shared libraries that all the product teams use on iOS. Then we've got all of the product teams on top of that use that shared infrastructure and oftentimes contribute to it as well. And then on top of that, we have the release team who makes sure that the product goes out the door on time, stable, and solid. All right, so I want to go through now just a little bit about our development platform. And how many iOS developers in the room? Yeah, OK, fair number. Actually, know some of my iOS Stanford students are here, so hi, guys. All right, so really quick, this is an Xcode project. You know what this is. Xcode projects, they encapsulate a lot of different things. Your class files, all the source code that you write. All of your resources, maybe some images, audio, video, your storyboards, your nibs, core data file if you have one,plists, strings file, because I expect everybody here is doing localization. All of that stuff is part of your project file, of course. When you compile, your source code gets compiled down and built into either an executable or a library. And when you take the resources and the executable together, of course, they get bundled up into an application, gets code signed, and that's what you end up deploying. Now, there's another target type. So those top two are things that Xcode can produce as products. And there's a third type, which is the bundle, where it can take a whole bunch of the resources, the files, bundle them up, and that's a product. So projects are great. You know, it's the basis of how we do our work. They let you build and code sign, and they give you a bunch of different types of products. But if you've worked on any large applications, you know that a project alone is just too difficult to scale. And at Facebook, we don't just have one product. We have several. We have more than that, actually. And so in order for us to make this work, we had to step to a different construct that was introduced in Xcode 4, which is the workspace. So just a quick introduction to the workspace. What it does is it allows you to take several different project files, each of which produces a library, and then a final project file that encapsulates all of the other project files and produces an application, an executable. And all of those different project files can also produce bundles that contain all the resources that are appropriate for them. So at Facebook, we take all those bundles and the final application, we bundle them up together into an application thanks to the workspace. There's one other important piece here that I think is worth mentioning, and that's the configuration files. In order for us to get a consistent build across all of our different libraries, we have one single configuration file that allows us to make changes that will propagate through all of our builds, right? So let's say Apple releases a new product that has a new CPU, for instance. By modifying just the configuration file, we get that propagated through each of our project files. So this should be basic stuff. You guys can go read about it on your own. But the bottom line, a little summary on workspaces here. They provide the relationships between each of the projects and the targets. And projects are able to use the products of another project for the compiling. Now, build dependencies is not something new. I mean, that's been around. I hope every platform should have it by now. Even Xcode had it before workspaces came along. But what workspaces do that's really convenient is it gives you one common build directory that all of your products can get compiled into. So when you use a workspace to link them together, you don't have to have copy build phases and all these other things. So workspace is super handy. Oh, and another great thing about it is that all of the features that Xcode provides, indexing, searching, code completion, refactoring, they all work across your workspace seamlessly. All right, so I've talked about kind of the underlying structure that we use at Facebook, but I want to get into some of the different components. What are the different libraries that we build? And I'll go through a few of them here. What we've done at Facebook is we've paralleled some of our components to match what Apple does with their iOS frameworks, things like Foundation and UIKit. But we've also created new components that allow us to add new functionality and share it across different apps. So the first one, just to give you an example of what I'm talking about, FB Foundation. That's Facebook's Foundation library. It, of course, matches closely to Apple's Foundation library, which has the standard classes like NSString, NSDate. Well, we've added categories like NSAttributed-string plus FB Foundation that does different kinds of formatting automatically for us, or NSDate. And then there's some additional classes that we feel are fundamental enough to call them foundation classes. And an example of that is FB DateString formatter. So whenever you're looking at something like Newsfeed, where you see somebody's post and it says 8 hours ago, those are a set of strings that are generated by FB DateString formatter in a standard way and used across all our apps. Another library that we use very frequently, in all of our apps, is FB UIKit, which of course parallels Apple's UIKit. But it also adds, in addition to some categories, it also adds a whole bunch of different classes that we think are views that are common across our apps. Rich text view is like a UI label that takes an attributed string and allows us to even go and download some of the assets in the attributed string and embed them and render them in line. Accessible button is really handy. We use that a lot. If you have any buttons that are just based on images, you'll know that accessibility requires you to write extra code so that when the state changes for the button, you have to go and set your labels. Well, with this class, and it's really easy to write, with this class, you set that all up ahead of time, and as the state changes, your accessibility labels change along with it. And then our photo swipe gesture recognizer, right? So when you tap on a photo in the news feed, it comes full screen, and when you pull it back, it has this really nice kind of spring-loaded gesture that puts it back into place. We actually use that in several of our apps, and that's a gesture recognizer in FB UIKit. Now, getting a little bit away from what Apple has in terms of structure, we also have something like, we have FB Data Model. What FB Data Model has is our core data model. We actually use core data, and it has all of the model-based functionality that we've added, and we've bundled that up into one library. And the reason that's been incredibly useful is that with all of our apps, especially with trying to share code at a higher level, we're able to access the data model in a consistent way across each of our apps. Also, our queries to the network are consistent and then written to disk in exactly the same way. So sharing the data model was a big step forward for us. And finally, FB AppKit, probably the highest level of any of our libraries that we share. It has some of the common Facebook pieces, like the composer when you're creating a new message, the friend list, the sharing sheet, privacy controls, the capability for you to like, comment, or share any of the stories. All of that's encapsulated into our FB AppKit library. Now, these are also components just like the ones I talked about, but there's a different class that we call modules. And they represent the product focus UI and functionality that we may also share across some of our apps, or some of them appear only in our main Facebook app. But the point of the modules is it allows each of the product teams to stay mostly in their modules to be able to iterate quickly rather than having to share code across the entire project file. And then we do something interesting where we have a module manager. So each of the modules register UI. They register URLs with the module manager, allowing different modules that don't know about each other to navigate between each other. The goal here is to minimize the dependency between each of the products. And I'll give you a little example of that. So this is Newsfeed. You should be very familiar with Newsfeed. I hope you're familiar with Newsfeed. And this is a post from Ricky Gervais that he posted last week when I was working on my slides. You'll notice that in the top left of the post is his name. And if you tap on his name, it navigates to the timeline. Well, the Newsfeed and timeline modules are completely separate and don't know anything about each other. So how do we navigate from one to the other? And the answer is we send a URL. So when you tap on Ricky Gervais' name, you actually get the profile URL for his user ID. If you went and typed that into a web browser, you're actually going to get his user ID, his newsfeed page, his timeline page. And we throw that into the module manager, and we say navigate to that URL. And sure enough, the module manager knows that the URL starts with profile. That means there's a UI in the timeline module that it knows how to pull out and push along the navigation controller. Another use of our URL segues is with our navigation bar, our tab bar, excuse me. Each one of those tabs down at the bottom represents a different piece of UI from each of our different modules. The first one is Newsfeed. That's from our Newsfeed module. Second one is Requests. That comes from our Friends module. Messages comes from our Messaging module. And the most interesting thing about this is, for the most part, identical to the UI you get when you launch our Messaging app. Right? We basically use the exact same UI. That module gets pulled out and put into our Messaging app, which is a subset of the functionality. Our Notifications module produces this UI. And before I get to the last one, each of these modules has registered a top-level URL that the tab bar knows how to render. And then there's our More tab. Well, every one of these modules has also registered the full list of things that it wants to be at a top level. And we've done some sorting, and we have some custom behavior to make sure that things appear the way we want. But then everything in that More tab is easily navigable via URLs. Now, one additional thing that this gets us, if you come from, let's say you get a notification from Facebook, and that notification links to a timeline or a certain newsfeed post or a message, those same URLs are the ones that come through from the notifications. So we made it really easy to get that functionality as well, thanks to our modules. All right, so to change gears a little bit, I want to dive into our toolbox and go through some of the different classes that I think are interesting in the way that we build our apps. And the first one is MoGenerator. Now, this isn't something that we built at Facebook. This is actually an open source tool, and I'll give you the URL for it in a moment. But what it does is it helps us build the source code for our core data model. If you've ever worked with core data, you know there's this handy feature where you draw up your model using this UML-style diagram, and you press one button and you say generate source code, and it goes and it creates all these source code files. Super handy. What's the problem? Overwrites. Every time you make a change and you generate, it rewrites those files, and you lose all the other stuff that you wrote. It sucks, actually, from that perspective. Well, somebody went and made this script that takes your data model and it breaks it out into, it generates two sets of classes when you run it through this script. It generates machine files. And the machine files have code that you can overwrite as often as you want, because you, as a developer, are never going to touch those files. But they are the base classes for your data model classes that you run at runtime. And then it generates this second folder that it called human files. And that's the placeholder for custom logic, and it's preserved across each of the model changes. So when you go and you regenerate those files, there's nothing that needs to change in the human files. They're completely empty when they're generated, so there's no need for them to ever replace them. So this has been incredibly handy for us. The URL is down at the bottom here. It's a GitHub URL. And just to illustrate that really quickly, so here's our core data model. Here's a core data model with one entity in it, and it's got my attribute and my relationship. When I run it through the script, the MoGenerator script, it produces two folders, machine and human folders, each one with two files, a header, and an implementation. Note the underscore in front of my entity. That underscore is actually the base class, which is a subclass of NSManageObject, but it's the base class for my entity. All right, the next tool I think is really interesting, and again, we rely very heavily on core data, which is something that we call FB Managed Object Observer. Any users of KVO? Yeah, I use KVO a lot. I love KVO. One of the problems with KVO is that every time a property changes, you get a message, which is great, handy. But if you have an object that changes significantly and has several different properties that change, you're going to get as many messages as you have property changes. And so let's say you're looking at Ricky Gervais' timeline page, and we have a Ricky Gervais object in our database, and he's got all kinds of different properties in there that change from one day to the next. Instead of getting 20 different property changes, each one causing a reload of the page, what we've done is we've set up this FB Managed Object Observer that aggregates all of the changes that happen on a single model object, and it batches them. So we get one notification that the object has changed, and then we're able to reload the page once. And it's actually a lot faster than KVO. Another kind of random tool from our toolbox is something called FB Tracer. Right? Anybody ever add logging to your code that says like, nslog start time of some function, and then you add the end time later, and you subtract them? Well, super handy. Sometimes you still do that, but we've tried to turn this into an object that we can reuse, and it's called FB Tracer. And what it does is it allows us to streamline our clock time measurement. Not only that, but it generates an object that we can pass around. So if you want to start measurement somewhere random over here, and then pass it into some block that you want to end the measurement, it actually tells you the time difference across those two things, because you have an object that's tracking it. And to keep performance high, so that it's not impacting performance, anything that we trace that's less than a millisecond is not logged. So just really quickly, here's what the code would look like. I have a method. I generate FB Tracer start. I get an object back, which is my tracer ID. Sorry, not an object, an identifier, a number. And then we pass that around, and we call FB Tracer stop on it. And what it does, it actually logs it to the console. We also have a way of collecting those logs and sending them up to a server. And it's all built into the same thing. All right, so this is less about classes in our toolbox, but this is a really handy tool for developers. And it's something called Lint. And there's a tool called Fabricator that we use as a general part of our workflow. It's how people check in code at Facebook. There's a part of that tool called Lint that allows us to catch common mistakes before the code ever gets into the tree. Basically, it allows you as a developer to create rules to check for certain misbehaviors in developers' codes. It's all regex based, so you can do things like enforce style guidelines, right? You can make sure that your indentation is right. There's no extra spaces. You can warn against unused symbols. You can check for common pattern mistakes, and it helps you fix them too. So with your scripts, actually I'll walk you through. And this is an open source tool that you can go and check out. So here's a little bit of code. Just two quick methods that just to illustrate the point. In setup accessibility, we're setting self.myView.accessibilityTraits. We set this number, this enum, UI accessibility trait header. And then we have a dealloc, and it does something dumb in there, and we'll talk about that in a sec. Well, what's wrong with this? Technically, there's nothing wrong with this, except that on iOS 5, this would cause a crash, right? And this bit us a couple times until somebody decided, you know what, we should write a lint rule for this that prevents anybody from using this again. It doesn't prevent anybody. It just warns the user when they try to check in code that uses this. And so when somebody tries to check this in, they get a warning that says, hey, look, this is going to cause a crash on iOS 5. So I could go back and rewrite that code and have an if around it that says if iOS 6 plus, call that. The next one is actually a silly error. You should know never to do this. Don't ever call dealloc on anything other than super. But people make this mistake sometimes. But what they really mean, and they always mean, is to call release on the object. And with lint, you not only have the ability to detect that, but you actually have a way to have the user fix it as well. So when they see the error that says, hey, you're not supposed to call dealloc, we also have something underneath that that says, did you mean to call release? If so, press yes, yes, and it fixes it for you and checks it in. So lint rules, regular expression-based, but it has some positive and negatives, right? For example, if you have some rules that check for dot notation instead of braces, well, people like to use them interchangeably. Or let's say I write some comment that says, I don't want to use UI accessibility trait header because it's going to cause a crash on iOS 5. Well, the lint rule is going to fail on that and give me a warning when I really didn't use it in code. So instead, we've gone and built this ourselves, which is an AST lint rule. And it actually uses Clang. And Clang is a fantastic, flexible compiler, and it generates a syntax tree for us. Then, instead of parsing the strings in the source code file, we parse the symbol tree, the syntax tree. And we're able to understand the code. It's the same way that static analysis works. And so we're able to build these richer lint rules. And anyway, it's something that we just came up with. And I think there's more work happening on it soon. So just to recap on the lint stuff, we have a regex lint rule that happens before the user tries to use Fabricator and check in. And then we have a more sophisticated Clang-based lint rule, which is brand new. So one other quick feature of what we've done with Fabricator is we now do our static analysis on every check-in on the server side. Right? If you've used static analysis, it can take very long to run. On the Facebook code base, it could take more than an hour to run. So nobody ever runs it. So we decided, let's put this as part of our continuous integration. All right. So the next thing I want to talk about is some of the things we do with testing at Facebook. As you may know, Facebook doesn't have big QA teams. And we're proud of the fact that we don't like to have engineers that are only focused on writing tests for the code. We believe that developers are responsible for their own code, and they're supposed to write the tests to do that. Well, in order for us to do that, we've built up a suite of tools around testing that we think are very valuable. The first one is Snapshot unit tests. And this has been available on other platforms, but it wasn't available on iOS, and it's something that we desperately needed, so we went and built it. So with Snapshot unit tests, we now have a way of taking a view and comparing it at build time to what we think it should look like. And so here's an example of something that actually failed at Facebook, a test that caught a bug that somebody was about to check in. On the left is what our megaphone was supposed to look like. Megaphones are our announcements, the way that we announce new features inside of apps. And if you look at the code here, so that yellow the button that's almost yellow there, is the way it looks when the enum is set to prominent, which is 2, right? And of course, the old code had a simple case statement that would return a string. and if the value is 2, it would return the string prominent. Well, somebody decided to get a little more clever about this, and so, which is fine. They wrote the following code that iterates over the values and returns a string. But they had an off by 1 error, right? So as we're iterating through here, instead of returning prominent, they were returning, sorry, they're iterating over the strings. Well, when they got to subdued, they're actually returning prominent. And when they're returning prominent, they're returning default. And so we had this, like, it's just a bug. It was a visual bug. But the bug never actually made it into the tree because our snapshot unit test caught it. So super, super handy. Now, another great thing about the snapshot tests is that, sorry, I went one too far. Another great thing about the snapshot test here is that it actually prints out this thing to the console, which don't try and read, don't bother. But it has this super handy little command that if you run this command in Kaleidoscope, it actually gives you the before and after of the views. So it's really easy. A lot of our developers have Kaleidoscope installed. It's really easy for them to see what they broke before they ever check their stuff into the tree. And we open source this tool. We posted it a few weeks ago, and you can go get it at this address below. All right, another thing to talk about with how we test things at Facebook. Well, because we don't have QA, we rely on our entire employee base to be our guinea pigs. And so this is a snapshot from my phone. I actually have 4 versions of the Facebook app on my phone. I really do. But one of the things that we've done that was really handy is we've put different icons for each of them. These are all the Facebook app. This is the same one, but they're at different stages of development. On the right here, we have something that I actually generated off of Xcode. I built it myself off my own machine. This is our release candidate. So I think Jocelyn this morning spoke about our master and release process. This is our release candidate. It actually has the build number baked in, which we do at compile time, which makes it really easy to identify which build we were using when you catch a bug. This, of course, is the download from the App Store. And this one is our master. So this is kind of our sandbox where we're trying stuff in. And it also has the build number baked in. Now, the way we're able to do that is having different bundle IDs for each of our builds. And those are the 4 that I just mentioned. The thing that I think is really interesting here is that we've burned the build number into it. All right, the next thing that I think is really interesting in the way that we build things, we like to build our features with off switches. People use our master tree as their sandbox. And sometimes things aren't quite ready when they check them in, but they have a way of turning them off and turning them on for their own testing. And the way we do it, remember what I mentioned with modules before? Well, modules have a way of registering features that go into our internal settings. And then our internal settings panel gives you all of the different registered features with on and off switches, or more sophisticated UI. You can have different parameters that you can change. Or you can even trigger events, right? So some of the events in here, we want to see the effects of triggering certain URLs to see how they navigate throughout the app. So this has been really handy. All right, now I think this is the last thing. There might be one more thing after this. Something that we built very recently that's been super handy for us is a Watchdog Timer. You've probably heard this terminology before. The Watchdog is something that Apple has on their devices where they kill your app after 10 seconds if you haven't been able to respond to an event on the main thread. Well, so this is your main thread. Your main thread's doing a bunch of work, right? Here's some block of code that it's executing, and then you return to the run loop. There's some other block of code. Well, what happens when you get to this point, and there's some giant block of code that's going to run and not return to the user? Well, the user's going to see a stall. They're going to get dropped frames. They may not get control at all. What we've done is we've set up a max priority thread that basically pings the main thread and waits for acknowledgement. And if it gets an acknowledgement within a certain amount of time, everything's OK. But if it doesn't get that acknowledgement, like in this last case, we're running this giant block of code at the end, we freeze the main thread, we take a stack trace, and we log that to our servers. And well, why is this important? Well, isn't Apple's Watchdog going to catch it? Well, we have the ability to turn the dial. We can make that shorter, right? So, like I said, our employees are the guinea pigs for this. But we're all running iPhone 5s and 5Ss. I mean, we're always on the new stuff. But we have a lot of users that are still using iPhone 4s, right? So we want to turn this Watchdog timer down so it's detecting stalls of 1 second. And so this way, we're able to catch anything that really stalls the main thread. So how it works, we have the max priority thread. Every X seconds, and X is tunable, it captures the main thread, freezes the main thread, captures a backtrace, and then it sends it to us for analysis. All right, the last thing I want to talk about is something that we call shake report, right? And you've seen this before. Google has recently added it as well in their Maps app. You have any problems, you shake it. Well, we've had this for a long time. And the way it works is if you run into some bug as an employee on your device, all you do is you shake your device. A little out of frustration, you give it that, action. And the great thing about that gesture is it doesn't require you to touch the screen at all, right? If you touch the screen, it might be disrupting whatever state that it's in. We want you to not have to touch the screen to do this. And so when you do this, there's a bunch of stuff that we collect. One, we get screenshots. We take a screenshot of the device, and we annotate it. We actually put the coordinates onto that screenshot. We give you network logs. We capture the last crash log and the last several seconds of logging. I think it's 20 seconds of logging, NS logs. And it gets the view hierarchy as well, right? So we collect all that stuff up, and we automatically send it to Facebook, and we file a bug. And we've got all kinds of infrastructure on the back end to collect these logs and figure out which ones are important. But the point here is that we make it really, really easy for our engineers, our entire employee base, to report a bug. And it's not something that we have in our, if you went and shake your Facebook app, it's not going to send us a bug. It's turned on only for employees. But it's incredibly useful. So that's all I have. Thank you. I hope this was useful. There's a lot of unique things that we do with iOS at Facebook. I've never worked on an app of this scale, and it's been really eye-opening for me to see how we do it. So, thank you. Any questions?
That shake report is very clever. Wanted to ask you, it seems like you've done so much great stuff. What are the major upcoming milestones that you're working on?
Well, next year we're launching, no, I can't tell you. I'll tell you what my team is working on in London. So we're taking we're building Newsfeed. So we're taking Newsfeed and trying to make it into a platform for the rest of the company. We use Newsfeed pretty heavily across our products, and that's our challenge. Yeah. So.
Thanks. So I was writing down everything you were doing for your Facebook development, and I noticed that Xcode 5 with continuous integration and a lot of new tools that they're bringing in cover some of the same bases. How do you feel about the new Xcode 5 and all the continuous integration and all the other features they provide?
I think it's great that Apple's getting into that space. We have a system that's pretty well developed and solid. We deploy to hundreds of different build machines at a time. I don't know to what extent we've tried Xcode 5. Doesn't work for us. Yeah. So I think the truth is the scale. It's great for smaller companies. The scale that we operate at is not sufficient.
You talked about modules and how they abstract basic components of the Facebook app. What kind of shape do they take in code? Are they bundles?
That's a good question. So when we build our modules, each of the modules actually produces a library that gets linked into the final executable.
Static It's a static library.
Static library, yeah.
Do you know why they killed the dynamic frameworks in
They
iOS?
never had it on iOS, right? So
Oh, they never had it?
on iOS, they never had dynamic frameworks. It was only ever static libraries, bundles,
Do you know why?
and applications. Security. So security. Well, I think also we don't have the ability as developers to produce those frameworks, right? I mean, I understand why they would be useful. I mean, it would be useful for us too, but you know, I can't produce.
The feature is there, they just have it turned off.
Right, but I can't ship a framework, right, on iOS. So
Companies are doing it though. You can, like there are different frameworks for iOS that you can embed into your app, and they're dynamic.
but you have to statically link it in, do you not?
It won't go in the app store. You can do it with enterprise.
With Enterprise, okay, yeah,
Yeah, they turn it off.
okay.
So you mentioned internal settings and feature switches. How much extra development, I guess, time and effort goes into having to build a feature and have a switch in the if-else statements, whatever it is?
Yeah, it's a good question. It's not that much more. I mean, there's definitely some forethought that needs to go into how you build your feature in order to make it be able to turn on and off. I'll tell you a little story. So last year, towards the end of last year, we had an experiment where we wanted to revamp our like bar down at the bottom, where it says like, comment, share. It used to be just, I think, a few text links, and we had this much richer, the buttons, the ones you see now. And what happened was we didn't have a great way of adjusting the size of our cells. And the reason that was important, because if you look at the new newsfeed, we have the like, comment, share buttons, but we also have some text above it that says, 3 likes and 6 comments. Well, if nobody's liked and commented on it, we don't want that space to be there at all. And so before we shipped the new UI, we didn't have this bug fixed. And we weren't sure whether it'd be OK or not. And so we showed it to Zuck, and we said, well, look, this is the bug we have. And we're not going to be able to resolve it in time because our cell heights are kind of static. And he said, it was a few days before ship, he said, let's not ship it. And we flipped the switch, and it saved our butts. We didn't have to do anything else to get that thing out the door. It just saved our butts. So I think there's lots of advantages to being able to thinking ahead and being able to turn on and off your features. So.
Hi. You talk about MoGenerator and Facebook Managed Object Contest, and those are really amazing tools, but there's a problem with big applications, which is handling different threads in different contests. And I would like to know a little bit more about how Facebook handles that. If you have any kind of tools, because in our company we use Magical Record to handle different, the synchronization between threads. And I would like to know if you have some tools or some libraries that you use
for doing, synchronization between threads?
Threads, and in the sense of accessing data and
with core data?
Core data, yeah.
Yeah, I could talk about that. So the way we've built things right now inside of core data, and there's lots of philosophies about how you want to build your core data access across threads. What we've come to is we have we only have 2 threads that access core data. We have one that we call the truth context, and that's in the background. So of course all of our network access happens and gets processed in the background, and we parse our JSON, turns it into objects on a background thread. And all that stuff gets produced into the truth context, which is our background context. And then our main thread context does no writing at all. It's strictly for reading. And so the idea there is, I think with parent-child context, you have the ability to read, depending on how you set up your parent-child relationships, you have the ability to read while the writes are happening and you won't get blocked. And so by doing it this way, as long as we maintain the rule that our main thread is not doing any writes, it saves us from getting blocked. Does that help? Yeah. 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 That's the problem. I think we're very conservative about how we delete objects. Yeah. So.
Hi.
Yeah.
You mentioned that you had 4 different apps of Facebook on your phone.
Yeah.
I was just wondering if you could talk about how you distribute those to your employees.
Yeah,
or
absolutely. So, I mean, obviously the Xcode build, that I don't have to explain that one, right? I just build and run, and I've got my provisioning profile. The App Store build is just a download, so those 2 are easy. For the other 2, the master build and the RC build, those are signed with the enterprise distribution profile. And then what we do is we post those builds to an internal website. And we, people navigate to that, employees navigate to that on our internal network. They click on it, and with the enterprise distribution profile, it downloads it and installs it directly. We do something else that's really interesting that I think I can mention, which is we have something that we call a nag. And if you've been running an old build of the app for some period of time, let's say it's a day or 2 days, we build very frequently. If you've been running the old build for over 24 hours, next time you launch that build, we're going to tell you, hey, you got to go and update. And we give them a button that says install, which sends them over to the web page, and then they can go and download it immediately. It overwrites the old one, yeah. So because the bundle ID is the same, the installation process takes it off. So.
In order to turn on and turn off a feature, is the feature needs to be developed in follow some pattern so that you can easily manage it?
Absolutely. I mean, I think people, the engineers need to build their features in such a way that they're gating the old code with, well, in this case, it's a preferences setting, and keeping the old code in a good state. Right. So sometimes you add a new feature. You're not replacing something old. It's easy to just gate that. The tough one is when you're actually replacing old code. There's definitely some challenges around it. I think the lesson I've learned, or the point that I'm trying to make is that if you think ahead about how you would do that, if you think about it as just it's one of your engineering constraints in what you're building, there's a solution. And so we just want to make sure that people think about that ahead of time. Does that help? Yeah.
So a quick question about the separate modules, and you were talking about compiling other resources and things like that.
Yeah.
Do you have any difficulties you've run into with different non-compiled resources like nibs, and nibs are compiled, but images, all those other things like image XE assets, things like that? Do you truncate those into the modules themselves, or is it like, how do you manage that?
So the only problem that I've had with the modules is the time it takes to deploy for Xcode to deploy to device, right? Because what we're doing is we're actually keeping the whole folder intact and then moving that into the app bundle. And there's some advantages to that. One of the advantages is that there's no namespace collision between modules, between different resource names. So if somebody has, let's say, something called a likebutton.png in this module, and they have another one called likebutton, they're completely different folders. The problem is when I deploy to device from from Xcode, it doesn't know to check for the existence of that file before it copies it again. And so you get this incredibly long file copy process every time you deploy to device. So that's the only problem I've run into. Yeah. So this last question.
Can we have your thoughts on iOS 7, Android 4.3, and the new features that were put into Xcode in the last rev?
Well, the Android one is easy. I don't touch Android. I'm like, no Android for me, thank you very much. I like my little sheltered Cocoa world. I'm happy there. I like iOS 7. I think Apple needed to do that, and I think they pulled it off very well. I think it was 6 years of the same UI, and it was an incredibly solid and incredibly intuitive UI, and they needed a refresh, and I think they did a great job with it. Xcode 5 seems to perform better, which I always like. Xcode 4 was so much slower than Xcode 3 too, but Xcode 5 seems to be coming back. I'm really happy that they're getting into the unit testing business, because that's something that it's not something that Apple does, but it's something that it feels like the rest of the industry does as a rule. And so to have that part of our development environment is really nice. Can you repeat the question? Yeah, I'll repeat it. So the question is, what do I think of the new changes to Objective-C? Do you mean like blocks, or I mean?
Yeah, just their with the Clang compiler. Sorry.
Yeah.
With the Clang compiler and all the changes that they're doing to the LLVM and all the direction of Objective-C.
Well, I have mixed feelings about Arc. Arc is incredible. It does really, really well. But when I interview people, the number of people that come back and say that they don't understand memory management scares me. So please, everybody, go and understand memory management. That is the most important thing you can learn if you want to be serious about iOS development. So anyway, honestly, I haven't dived in that deeply into some of the other things. So anyway, thank you very much.